Welcome to Module 3, Ratio, Proportion, and Variation. So ratio, this is a comparison of two or more numbers that indicates their sizes in relation to each other. This is also the quotient of two numbers or identities. So for example, A over B, or the ratio of A to B. And another example, 5 is to 12. So 5 is to 12 can also be written as 5 over 12. And then another example is x all over x plus 2 divided by x squared. And then finally, another example is feet over yards. So these are examples of ratio. Proportion, these are equations of two numbers or identities. This states that two ratios are equal. So for example, number one, we have here A over B is equal to C all over D. So we know that A all over B is a ratio and C all over D is also a ratio. So proportion states that two ratios are equal. So A all over B, the ratio of A to B is equal to the ratio of C to D. And this one can also be written such as this. A is to B is equal to C is to D. Another example, x over y is also equal to 10 over 3. Or x plus 1 divided by 5 is also equal to the ratio of 2 over 2x plus 3. So in this particular example, A is to B is equal to C is to D. A and D is called the extremes, and B and C is called the means. In any proportion, the product of the means is equal to the product of the extremes. Or if we are to put this statement into an equation, that simply becomes BC, the product of means, is equal to the product of extremes, which is AD. So BC is equal to AD. So example, number 1, x is to the quantity 25 minus x is equal to 3 is to 7. Solve for the value of x. So we can see that this particular problem is a proportion. So proportion again states that two ratios are equal. So x is to 25 minus x. This is one ratio. And then 3 is to 7 is also another ratio. And accordingly, it is equal. So therefore, we can say that this one is a proportion. So going back to this problem, we can simply write this one. We can also write this one as x is equal to 25 minus x. That is equal to 3 over 7. So applying the principles of algebra, that is 7, x times 7, that is 7x, is equal to 3 multiplied by the denominator, that is 25, minus x. So simplifying, this is 7x is equal to 3 times 25 is 75. And then 3 minus x is simply 3x. Transpose this 3x over here, so that becomes positive 3x plus 7x is equal to 75. So 3 plus 7 becomes 10x is equal to 75. So divide both sides by 10. X now is equal to 75 over 10. So x now becomes 75 over 10, or simply x is equal to 7.5. So this is now our answer. So we have here example, x is to 25 minus x is equal to 3 is to 7. Solve for the value of x. So again, we can say that this one is a proportion because the proportion states that two ratios are equal. So we have here your first ratio, x is to 25 minus x, and then the other ratio is 3 is to 7. So this is proportion. So we also said that in proportion, the product of the extremes is also equal to the product of the means. So this is our means. So the product of the means is also equal to the product of the extremes. So that is simply b multiplied by c is equal to a multiplied by d. So b, that is 25 minus x multiplied by c is equal to a. This is our a, that is x. So a, that is x, and the d is 7. Simplifying, 3 times 25 is 75 minus 3 times x is 3x is equal to x times 7, that is simply 7x. Transpose negative 3x to the other side. So this becomes 75 is equal to 7x plus 3x. So that becomes 75 is equal to 7 plus 3, that is 10x. So divide both sides by 10. Cancel, cancel. X now becomes 7.5. So this is now our answer.
Next problem. The area of a quadrilateral is 64 square feet and its longest side is 10 feet long. Find the area of a similar quadrilateral whose longest side is 15 feet long. So we have a quadrilateral, and when we say quadrilateral, this is a polygon with 4 sides. So we have here a quadrilateral with an area of 64 square feet. So let's name it area 1 since we will be dealing with two quadrilaterals. So let's specify it. Area 1 is equal to 64 feet squared, and the longest side or the length is 10 feet. So that is L of 1 is equal to 10 feet. And then we are to find the area of a similar quadrilateral whose longest side is given to be 15 feet. So that is L of 2 is equal to 15 feet. And we are to find the area of this second quadrilateral. So with the use of the ratio and proportion, we would be able to solve the value of area 2. So first, let us designate this as width of 1, and this is width of 2. So since we know the length 1 and the area 1, we will be able to solve the value of width 1. So area 1 is simply area of rectangle is length times width, that is L1 times W1. So area 1 is given to be 64. 64 feet squared is equal to L1 is also given to be then 10 feet multiplied by width 1. So width 1 is 64 feet squared divided by 10 feet. So the feet and 1 feet will cancel out. W1 is simply 6.4 feet. So using ratio and proportion, we will be able to solve area 2. And that is simply the ratio of length 1 is to width 1 is also equal to the ratio of the length 2 and width 2. So substituting, L1 is 10 feet. With 1 is the one you're able to solve. That is 6.4 feet is equal to length 2 is given to be 15 feet over W2. So once we solve the value of W2, we can solve for area 2. So feet and feet will cancel out. This becomes cross multiply W2 times 10. That is 10 W2 is equal to 6.4 times 15. That becomes 6.4 times 15 feet. So W2 is equal to 6.4 times 15 feet divided by 10. So W2 is 9.6 feet. So since we already know the value of W2, we can now solve for area 2. And that is length 2 times W2. So length 2 is given to be 15 feet multiplied by W2, which is 9.6 feet, yung na-solve natin. So area 2 is 144. Feet times feet becomes feet squared. So this is now our answer.